We've looked at the rules for assigning significant figures. Now we need to see how we handle these when we get into calculations, and so that's the purpose of this lesson. Now when doing calculations, we actually have two separate rules that we have to worry about. The first applies to addition and subtraction. The answer of a sum or a difference between two numbers is based on the least number of decimal places. So when I look at adding these two numbers, 1.2 plus 3.31, if I enter that in my calculator or add it up, what I find is 4.51. And if we were just adding numbers, that would be fine. But we're not adding numbers, we're treating these as measurements. So as a result, our answer cannot be more precise than our least precise number that went into it. And so when I look at the two possibilities, the 1.2 is the least precise number, and it only has one decimal place, and as a result my answer can only have one decimal place. So for addition and subtraction, the answer's number of decimal places in the answer must match the least number of decimal places in the number that was started out in the calculation. So here's another example, adding three numbers together. What we see at the bottom is the calculator answer, and we need to figure out what the actual answer is if we're treating this as a measurement. So what we need to look at is the least precise number. And notice that we're never worried about the digits to the left of the decimal point. We don't have to worry about these. The only thing we worry about are the digits after the decimal point. And in this case, we have two digits after the decimal place, and so therefore our answer must also have two digits after the decimal place. So our answer should be 34.22. Now for the second rule dealing with calculations and significant figures, and that applies to multiplication and division. And our answer in this case is going to be based on the least number of significant figures in our answer. So when I look at the two numbers in my problem, I see that I have 1.2, which has two significant figures, and I have 3.31, which has three significant figures. Therefore, my answer can only have two significant figures. Again, when I put these numbers in the calculator, the value I get is 3.972. And so I can only keep two digits. So this 7 will be the first number that's dropped, and that's what actually determines the rounding. So I round to 4.0. Notice that I did not write 4 because that is a lower level of precision than I can have, and I always want to report answers as precisely as possible. So here's one for you to try. Which answer has the correct number of significant figures? We're giving you the calculator answer here. You need to pick the correct answer. When I look at my 7.814, we have 4 sig figs. 0.30 has 2 sig figs. Remember, this first 0 is just a placeholder 0. The 0 at the end is after the decimal point, so it is significant. And then 22 also has 2 sig figs. Therefore, my answer can only have two significant figures in the answer. And as a result, I'm going to have to cut it here. 5 is the first number that's dropped, and so anytime we have a 5, we always round up. And so the correct answer will be 52. There are some numbers that we don't have to worry about when we look at significant figures in calculations, and those are known as exact numbers. So for example, if a number is obtained by counting, so 8 people, 6 eggs, we have exactly 8 people or exactly 6 eggs. I can't have 6.2 eggs or 8.5 people. I have to have a whole number there. So those are considered exact numbers. So if these were involved in a calculation, we would not look at those for determining the number of significant figures in our answer. Other examples of exact numbers are 2 units in the same measuring system. So 1 quart and 4 cups. Any of our metric conversions, a kilogram to 1,000 grams, 1 foot is 12 inches, those are all exact numbers. Usually, exact numbers are a whole number, but that's not always the case. One key exception is looking at the conversion between inches and centimeters. Although this is a fractional number, this is an exact number. The same is not true when we look at miles to kilometers or feet to meters, anything like that, but for this particular relationship, this is an exact number and should not be used in determining the number of significant figures in your answer. So when we're rounding, I mentioned earlier that we always look at the first digit to be dropped to determine whether we round up or round down. So in these two examples, the number that's underlined is the last digit we can actually keep. So for the first one, the last number we're keeping is 2. The first number that's being dropped is 1, and that's the only number that I look at to determine if I round up or down. Even though there's a 9 after that, that doesn't matter. I look at the 1 and say that number is less than 5. So if this is rounded to 4 significant figures, my value will be 3.402. For the next example, we have 10.3911. The 3 is underlined, indicating that that's the last digit we're going to keep, and so we look at the 9, which is the number immediately following it, to determine whether we round up or down. Because 9 is 5 or greater, we're going to round up. So our answer would be 10.4 if we were trying to round to 3 significant digits. Now, a frequently asked question is, what do I do in the middle if I'm doing multiple calculations? So many people are working on your calculator and the number's kind of saved from the previous step, and that's perfectly fine if you carry it all the way to the end. If you happen to be writing something down, you don't have to write down every digit. A good rule of thumb is to keep one extra digit and round at the end. This may result in some slight variations among people if you're doing the same calculation. That's perfectly fine. The homework system and the exam questions are set up to accommodate a range of answers that do not depend on whether you rounded exactly the same way at exactly the same step throughout the problem.